Okay, so here we're looking at problem number 16 on set 1.1. And what I'm going to do is I'm actually going to give you a little rundown of the interval notation, because that seems to be what's giving you a hard time, right? So let me go ahead and bring up a blank whiteboard, and I'll explain those to you. All right, the interval notation is a very efficient notation. Okay, so it looks like this. So let's say you have the set of real numbers, right? And I'm just going to use an example of a number to make it easier. So let's say I want to look at all numbers that are greater than 2, like that, right? So what I'll do is, there are two ways I can express those numbers. One is I can use the set builder notation. I can say that is all x, that means all real numbers x, such that this bar right here means such that, it means I'm about to describe what kind of numbers, right? Such that what has to be true? X has to be what? Greater than 2, right?
Yes.
Like that, okay? So this right here, we call that set builder notation, because I'm not giving you all the numbers that are in that set, am I? But what am I doing? I'm describing it. I'm telling you how to build the set, right? So therefore, this is called set builder notation. Now, we have a much more efficient notation for describing these numbers. That notation is called interval notation. This one is called set builder notation. And this one is going to be interval notation. So for this one, an interval is basically a chunk of the set of real numbers, right? The set of real numbers is, of course, the number line. Every number on the number line is called the set of real numbers. But what if we want to look at just a piece of it, right? Now, the piece could be finite, like the one we saw before, like the numbers between 3 and 5, for example, or it could be infinite, right, as far as the length of the piece is concerned. So, for example, right here, all numbers greater than 2. If you look at that part of the number line, that's almost like you can think of it as half the line. It's what? It's infinite in length, right? So for those, now, if it's between just two numbers, 3 and 5, we can just go parentheses, 3 comma 5 parentheses. But here, we don't have an end point. We have a beginning point, but we don't have an end point. So we say these numbers are headed toward infinity, right? So in other words, you can think of the end point as infinity. Now remember, infinity is not an actual number, right? It's a numerical concept. So we go like this. We say parentheses. We put the beginning point of this set, right? What is the beginning point? It's 2, right? So we put 2, comma. Now where does it end? It doesn't end. So we put what? Infinity. Now, the question is, when do we use parentheses and when do we use brackets? Because you've noticed on some of the problems there are brackets, on some of the problems there are what? Parentheses, right? Okay, you use parentheses if the number, the particular endpoint is not included, right? In other words, when you have an open circle on the graph, right? So you use a parenthesis next to it. That means we want all numbers starting with 2 and then to the right, but not what? But not 2 itself, okay? So how do I include? Remember, this one here is called what? Interval notation. I'm still getting used to writing with this little tablet. Not as natural as just writing straight on the computer, but it's better.
It looks good. It looks good.
You can read
It's
it, right?
readable.
You can read
It's
it?
readable. Yes.
Look, as long as you can read it, we're good. All right, so now, this time, I want to include the 2, like that, okay? So I want to look at all real numbers that are not just greater than 2, but also what? Equal to 2.
Yeah, greater
Okay.
than or equal to.
Right. So now the set builder notation is going to change like this. This is going to be all x such that x is greater than or equal to 2. You see, a subtle difference, right? But important. Now, also, the interval notation is going to change for representing this set, right? Instead of having parentheses 2 comma infinity, we're going to have what? Bracket 2 comma infinity. Now remember, you never put a bracket next to infinity, to the right of infinity, or to the left of negative infinity, because you only put a bracket if you're including a number, right? And remember, infinity is not an actual number, so we don't include it, right? So that's always going to have a parenthesis next to it, okay? But the 2 we want to include, right? So remember, an open circle is associated with what? With parentheses, either this or close parentheses. A full circle, or in other words, inclusion, is associated with what? Bracket. If it's on the left you're including, it'll be a left opening bracket, or if it's on the right end, we put a bracket like that. So now let me ask you this. You tell me, how would you represent this set? What would be the set builder version of describing this set? What would be the definition of this set in set builder notation? All x such that what?
Less than.
Yeah, so x is less than what?
2.
Good. All right, so remember, the way you write an interval, it's always beginning point, comma, ending point, right? Does this have a beginning? Does this set of numbers have a beginning?
No.
No.
Right, so we say it actually, the way we indicate that is we say it starts at negative infinity. That means what? That means it has no beginning, basically, right? So am I going to use a parenthesis here, or am I going to use a bracket?
Parentheses.
Always. To the left of negative infinity or to the right of infinity, you always use parentheses. So we have parentheses, negative. Remember, you always think from left to right, okay? So when we say beginning, end, always look on the left for the beginning, on the right for the what? For the end point, right? So it'll be negative infinity, comma, what?
2.
Exactly. Okay. Is 2 included?
No.
2 is not included. So we go ahead and put what?
Parentheses.
The bracket.
No,
No.
it's not included, right? Remember, bracket is associated with what? With closed circle and inclusion, right? Parentheses is associated with the open circle and what? Exclusion, right? Like that. All right, so here we're gonna have parentheses as well. So what if we wanted to include the 2? What would change? Notice I didn't put the negative infinity or in the infinity on the number line, because they're not actual numbers on the number line. They're what? They're numerical concepts. All right, so how is the set builder notation gonna change? And how is the interval notation gonna change? What's the set builder notation gonna be? All x such that what?
Less than or equal to.
Yeah, so x is less than or equal to 2. Good. And how is the interval notation going to change?
So it would be parentheses, negative infinity.
Excellent. Always parentheses next to infinity and negative infinity,
And
comma.
2 bracket.
Exactly.
Okay, cool.
All right. That's how it works. Let's go ahead and do the last two types that I want to show you. Now, these are all, notice, all of these are infinite intervals, right? Because their length is infinite. Now let's look at a couple which are finite. So what if I want the numbers strictly between 2 and 5? In other words, we're going to have open circles on both ends, right? So how do you think we represent that in set builder notation? We say all x such that what? Well, let me get this one going for you. This is going to be that sandwich notation, right? X is going to be sandwiched between what? 2 and
5.
5, right? So the way you read this, you say all real numbers x between 2 and 5, and you don't say anything else, right? As long as you just say all real numbers between 2 and 5, that automatically means that 2 and 5 are not what? That 2 and 5 are not included. Do you understand? So here, we're finished with that. So how do you think we'll write the interval notation? Remember, interval is always beginning point, comma, ending point. So tell me, parentheses or bracket?
Parentheses.
Good. What do I start with?
2.
2 is the starting point. What's the ending point?
5.
Right. And then what?
Parentheses.
Exactly, because 5 is not included either, right? All right. What if both 2 and 5 are included? By the way, this is called an open interval. The one we're doing now is called a closed interval because it's closed on both ends, right? All right, so first of all, what would change here? That would be all x such that what? 2 is, what would change?
Greater than or equal to?
You mean less than or
Yes,
equal to,
yeah.
right? X and then less than or equal to what? 5. All right, so how would the interval notation change?
So just the 2 and 5 in brackets.
Right, so it would be bracket 2 comma 5 bracket, okay? All right, so the last two that we're gonna look at are gonna be the, let me go ahead and see if I can move this a little bit. Oh, it's not moving because oh, I see. I'm actually using the Zoom annotation. I thought I was using the whiteboard's annotation. That's okay, this is fine too. All right, so here, we can do it here. All right, so this time I don't want to include the 2, but I want to include the 5, right? So what's the set builder notation going to be? All x such that what? 2 is what? Less than or equal to? This or?
Less than 5?
Yeah, no, 2 less than x, right?
Oh, less than x, right? Okay.
And then less than or equal to 5, right? All right, so the way you read this, you say all real numbers between 2 and 5, right inclusive, right? That means include this one, don't include that one, okay? So what's the interval notation going to be? Is 2 included?
No.
Okay, so parentheses or bracket?
Parentheses.
Excellent. So parentheses 2 comma, is 5 included?
Yes.
So 5 and then what?
A bracket.
That's it, okay? The last one we can have, this is the last possibility. What if we don't want to include the 2? We don't want to include the 5, but we do want to include the 2, like that, right? So set builder notation will be all X such that, so let me just put this and you tell me which one of them has to change into less than or equal to. Which one? The first one or the second one?
The first one.
Exactly, okay? And what will be the set builder, the interval notation?
So bracket,
Mm-hmm.
2 comma 5 parentheses.
That's it, okay? Just like that. All right, so notice the intervals where both sides have parentheses, those are called open, right? So here's an open interval, here's another one, here's another one, and the ones where both are brackets, we only have one of those, right? This one. That's called a closed interval, right? And the ones where one side is a parenthesis, the other one is a bracket, what do you think those are called? What's a good name? Half open, okay? Does that make sense? We could have called them half what? We could have called them half closed too, right? But we decided to go with half open. So these intervals where one side is parentheses, the other side is bracket, they're called half open intervals, right? So that's it. This is all there is to it, to basically to intervals, but extremely important. Once you move on to any more advanced classes, like if you were to continue with math and take calculus, etc., that's all you would see. You hardly will ever see set builder anymore. Set builder notation is extremely important, and you will see it from time to time. So you need to know it, but let's face it, which one is more efficient, right? When it comes to quickly writing it, you can see the power of the interval notation, right? You say a lot with so little writing, right? So that's that. All right, so who was it who wanted to know about intervals?
Can you just repeat what you said about the infinity, that it should never be next to is it
A bracket.
A bracket,
Right,
okay.
because remember, you only put a bracket either on the left or the right if a number is included. You get it? So like here, 2 is included in this set, right? So that's why you have to put a bracket next to 2. That means include the 2, right? But remember, you can never include infinity or negative infinity because they're not actual numbers to include, right?
Okay.
So to the right of infinity or to the left of negative infinity, you always have what?
A bracket. It's a parentheses.
Perfect. You always have parentheses. Make sense?
Yeah, that
Yes.
helps a lot. Thank you.
Okay, sure. So Casey, that was clear on that. We're good to go on that?
Yeah.
Okay. So let's go ahead and go back to the assignment now. All right. So now here, look at the graph shown in the first row of the table, which is also shown here. Write the inequality that represents this graph, right? So they don't want you to write the entire set builder notation, just the inequality that goes inside it, right? So notice here, you would just say X is what? What kind of X are we looking at? X that is, how do you describe this? What's 7 compared to 6? It's what? 7 is
Greater than.
Greater than.
right. So all these are X values that are greater than.
Or equal to.
Exactly. So 1 second. So this is all X greater than or equal to what? 6. You see that? Now they want the interval notation. So now I think you can handle it, right? So what's this in interval notation? Parentheses or bracket?
Bracket.
Yeah, bracket, and then what? 6, comma, where does it end?
Infinity.
Infinity.
Yeah, in other words, it doesn't end, right? So that's when we put infinity, and of course, always parentheses to the right of infinity. All right, so that's that. So then they want you to do kind of the similar thing with some other sets. They're just giving you a lot of practice here, that's all. So here it says, look at the following wording. Look at this wording. Numbers less than or equal to -4, right? So how would you write that? With an inequality? Numbers less than or equal to -4. That's all x what? Less than or what? Or equal to -4. Does that make sense? And it says, look at these numbers that are less than or equal to -4 given in the second row of the table. Choose the graph, right? So you just want to now pick the graph that represents it. So of course, you're going to want to find -4 with a full circle because it's included, and then everything to the what? To the left, etc. All right, so then there's just more practice like that. Any questions on that? Are we good with this problem now? Can you handle the rest?
Yeah, that helps a lot. Thank you.
You got it. Okay, what else? What else is giving you guys a hard time? So here you see, just to continue a couple more of these. Here you're look. How would you read this? First of all, can you read it for me? Just say it in plain English. How would you say this? These are all real numbers that are what?
Less than or equal to.
Well, okay. If you just want to say it in this regular, conversational English, we don't even bring in less than and all that. Here we just say all real numbers between, right?
Right.
Between
Okay.
what?
5 and 7.
Right.
Yeah.
Are both of the endpoints included?
Yes.
So I didn't tell you how to say that first. I told you what to say if the right one is included, right? I said we say right inclusive, right? And of course, you can imagine if the left one is only included, we would say what? Left inclusive, right? I didn't tell you how to say it when they're both included. When they're both included, you just say inclusive. You see what I mean? You don't need to say right and left inclusive. You just say what? You just say inclusive. That means both endpoints are what? Are included. So if you were to write this as an interval, right? What would it be? Can you tell me what it would look like as an interval? Parentheses or bracket?
Parentheses.
Look again.
Sorry, no.
You mean bracket because it's included, right?
Yeah, sorry.
So
It's just
bracket what?
like
No problem. No worries. It happens. Bracket what?
5,
5, comma,
7,
and then
bracket.
that's it. Is everybody clear on that now? Good. And then,
Yes,
of
thank
course, the graph is easy, right? You got to just make sure you understand that if this is 4 and this is 6, this must be what? That must be 5, right? And if this is 6 and that's 8, that must be 7. All right. All right, so any other questions on any of the sets that's bothering you? Anything else on 1.1? Let's talk about it that way. Anything on 1.1? Try to make the number of problems very manageable so you guys don't really feel overwhelmed. These were easy, right? Just locating numbers. think those interval notations are probably the toughest thing in this section, right? That's probably just because it's unfamiliar to some of you. Let me go ahead and bring up set to 1.2. See what we have there. See if you have anything that's bothering you there. All right. Sometimes it's Windows. All right. Go ahead and take a look at these. How did this go? This set go for you? You know the difference between an expression and an equation, right? Can you summarize it for me? What's the difference between the two? An equation has to contain a what?
A constant, a variable, combination of constants.
Well, that's partially true, but more importantly as well, you definitely have to have a what? Have to have an equal sign, right? Right. So, and the thing is, sometimes people get confused. Like if I write this and I ask some students, what is that? Is that an equation or expression? They'll see the equal sign and they incorrectly will say what? They'll say equation. But remember, it's not enough to have an equal sign. It's only an equation if you have an equal sign and an expression on the left and at least some expression on the right. You see what I mean? Now this is a what? This is an equation. But before I did that, right? This is an expression. Even though there's a what? Even though there's an equal sign, this is still a what? This is still an expression.
An expression, right.
By the way, just so you guys know, I don't know if you're familiar with Zoom to this level, but if you just quickly want to say something without having to go to this and go mute and unmute and all that, do you know how to do that by any chance? Anybody?
No, I'm new to Zoom.
Let me tell you a really nice, easy way of doing that. Hold down the space key, say what you want to say, and then let the space key go, and you'll go on mute again. Try it.
Oh, okay.
Nice, right? It's better than having to keep going over here and Zoom muting and unmuting and all that, right? All right. Okay, so yeah, that's a really nice, easy way of doing that. So just remember, just because you have an equal sign, it doesn't mean you have a what? You have an equation. You have to have an equal sign and some expression on the left, some expression on the right, yeah? So to evaluate is easy, right? What do? You just plug in whatever x value is of interest to you, wherever you see x in the expression, right? So that's easy. What's 1 plus 12? 13. So evaluate the expression 8c for c equals 2, same thing. Instead of c, plug in what? 2. Of course, when you see 8c, that means 8 what? What's the operation?
Multiply.
Right, that means 8 times c, right? That's where you get the 16, right? Here, the operation is division, right? So 42 over n, when n, so basically you can write it like this, 42, it means the same thing, right? So now you're gonna substitute what? 6, and what do you get? 7. If you notice, each one of us gets a slightly different problem, right? That's an anti-plagiarism move on the part of Pearson, and most of these online homework systems are like that. and it's easy enough for a computer to generate new numbers anyway. So there's that, which is really nice because I get to do a problem and you still get to do your own. You see what I mean? And learn it. So if a person buys N audio CDs, the total cost is 13N. So what does that tell you about the cost of each CD? Can you tell me? See, the thing about algebra that is so important, because this is pretty much algebra that we're doing right now, right? Algebra is the very first class in your life when you start moving from the concrete, right? Because arithmetic is very concrete, right? Everything is known, you just add them, subtract them, etc. Here, this is the first time you move into the zone of the abstract, right? That's why you definitely don't want to bypass algebra. That's why some of these new regulations which are letting people bypass it are very silly in my opinion. Anyway, so but then politicians, you know, what do they know, right? Okay, so 13 and that means basically each CD costs how much? $13, right? So they want to know, they want you to evaluate it for n equals 7, so you're just going to what? Substitute 7. That's where you get the what? The 91. Is that clear? Since you're not asking specific questions, I figured we'll just kind of go through as much of this homework together as we can. But if you have specifics, by all means, bring them out.
Well, I have a specific one.
Let's
It's
go
from
for it.
1.3.
Uh-huh.
It's question 16 of 19, and that
All right.
about the area.
You got it. 1.3.
Number 16 of 19.
All right. So 1.3, number 16 of 19.
And you have an area.
Got it. All right. So all right. So this one, right? So a rectangular plot of land has a length of 3. So let's go ahead and, whenever you have a situation that's geometric, it's really nice to do a quick sketch, okay? So we'll do a quick sketch. It's a rectangular plot, right? That's easy enough to sketch. And the length is 3/7 of a mile. Length is usually the side that is longer, right? And the width is 11/12 of a mile, right? Which is interesting because here they're giving you a width, which is actually what? This is actually
bigger.
long. Yeah, so let me go ahead and play their game, right? Let me just go ahead and call this one the width. That's unusual, but it's not a big deal. They're just names. All right, so they want you to find the area. Now, remember, the things you want to do with geometric problems in this order. First, do a sketch if possible, right? Then write down any formula associated with the situation you're dealing with, right? So what formula would apply here? Well, we need the formula for the area of a what? Of a rectangle, right? Don't plug in numbers. Just tell me what the formula is. What's the area for formula for the area of a rectangle?
Length times width.
Perfect. Okay. Now substitute. What's the length in this unusual way that they've defined it? What's the length?
11/12.
No, well,
11 over 12.
You mean 3/7, right?
Oh yeah,
Remember,
sorry. Yeah,
they did
because
it
of
backwards.
the wording.
It's not your fault, right? So 3/7 mile, and what's the width?
11 over 12.
Right. Now I put the miles in on purpose, okay? Because now I'm going to separate them. So now I'm just going to put 3/7 times 11 over 12. But I want you to see why the units of a area become squared. Because look, mile times mile. You see that? Let me ask you this. What is x times x? Do you know? That's x what?
X over power
X squared.
X.
Right.
Yeah.
That's x squared, right? So what's mile times mile? That's going to be mile squared, right? Now, we usually read this as what? We don't say miles squared. What do we usually say?
Square mile.
Square miles, exactly. So now here you're multiplying two fractions, right? So if we just want the general rule, it's a over b times c over d equals a times c over b times d, right? However, there's a golden rule. Only do this, in other words, only multiply across if you have already simplified both fractions, okay? So I look at 3/7 and 11/12, and I notice that there is some simplifying I can do first. Doing that is going to make your life much, much simpler because you're going to deal with a lot smaller numbers. You see what I mean? So here, 3 and 12, right? What's the, when I cross cancel, right? What do I get? Let me go ahead and actually do something so you guys don't even have to worry about it here. That way we don't have to worry about your videos being in there in case you're uncomfortable. All right, so help me out here and tell me how I can cross cancel. What is the cross canceling that's possible here?
Change the 3 to a 1 and the 12 to a 4.
Exactly. In other words, the way we say it is 3 goes into itself once and it goes into 12 4 times. What is what we just did called? Do you know what that process is called?
Simplifying?
That's called cross canceling, right?
Okay.
I mean, it is a form of simplifying, but specifically it's called what? It's called cross canceling, right? All right, so we end up with, now we go ahead and do what? Do this rule, which is multiply what? This is called multiplying across. You see what I mean? So what do we get when we multiply across? 11 over what?
28.
There you go. So 11 over 28 square miles is going to be the area. All right, let me bring this up so at least I know you're who I'm dealing with. Okay, so Katie, was that you? You got it now?
Yes, now I got it. What I was missing was I couldn't remember area equal length times width.
Right. And you know, that's fine. I mean, sometimes that happens. So let me just give you a little bit of a training as well here. It's a good opportunity to do so. Notice that when you're doing the problem, you notice this guy here? Right there, okay? You can click it. Let me go ahead and clear. So let me walk you through one of these settings, situations.
Yeah, I use that a lot and it does help a lot. I
Good,
did
good.
the view an example and
Right, now,
it does help.
yeah, at the time, I want you to use that secondly, okay? Not the first thing you use. But in a situation like this where you couldn't remember the formula, that's a perfect time to use view an example, okay? But if you do remember the formula and you still don't get it, I want you to use the first option first. That's a much better option, okay? Because this one actually walks you through the steps. You see what I mean? You end up doing the problem. That's the nice thing. You get it? It's like a good tutor, right? At the library where they don't want to just get rid of you. They actually want to teach you, right? So, so make sure that you try this first, and then if you still need more help, you can go ahead and click on view an example, okay? The nice thing is there are other options as well. There are video explanations, there are text, there's a textbook section. They can, when you click that, it takes you to the section in the textbook that teaches this kind of stuff. So if you want if you really want to gain some depth into a particular concept, that's what you would click. You see what I mean? You would go ahead and go into the textbook and you would read that whole section to get more depth, okay?
Okay, yes.
All right, so that's how. All right, so what else? We got any more specifics? See that? Really nice. It's very well done. And even when you're within the text, right? Hold on. Let me bring that back. Even within the text, you see that right there? That link, if you click it, that'll take you to a video, okay? Did you try any of those?
Divide if possible.
See?
The first example is 0 divided by 18.
Very nice.
It's okay for 0 to be in the numerator, or as in this example, to be
there. So there's a ton of information. I kind of feel bad for you guys. You know why? Because in my times, finding information was really hard, right? We had to go to the library, find 3 books, you know, this and that. So we had tons of excuses for why we didn't do something, right? Oh, we didn't do the homework. It was so hard. We couldn't find enough help. You guys don't have any excuses. So in that sense, I kind of feel bad for you. But anyway, yeah, it's good for you. But in general, I'm happy for you because you have so many options available to you. All right, so any other specific problems? Okay, if not, we're here, so we might as well just keep going here a little bit. For an elementary algebra course, total course points are calculated by adding points earned on homework assignments, quizzes, tests, and the final exam. If the total score on tests is worth 1/3 of the course points and the final exam is worth 1/5 of the course points, what fraction of the course points comes from homework and quizzes? All right, so this is actually a good problem because remember, when you have, let's say, how many parts are here, basically? How many categories are we dealing with? We're dealing with homework is one category, right? Quizzes are another one, tests are another one, and the final exam. So 4 categories. Is that clear?
Yes.
Okay, so, and all of them add up to what? So each of them is part of your one grade, right? So all of them add up to 100%, which is the same as what? What's 100%? That's 1. You get it? So here we say the fraction of the grade that comes from homework, like this, right? Plus the fraction of the grade that comes from quizzes, plus the fraction that comes from tests, and the final, they all add up to what? To 1. Does that make sense? 1 is 100%, right? Remember, 100%, that means 100 over 100, which is what? 1. So when somebody says, hey, put 100% of yourself into it, that means what? Put 1 whole of yourself into it. So that means what? Put all of yourself into it. Okay, so that's what we mean. So now they're saying the total of the course scores on tests is 1/3. So instead of test here, I'm going to put 1/3. And the final exam is 1/5. They want to know what fraction comes from homework and quizzes. So in other words, these two you leave as what? As is, right? So we're going to just leave this as H plus Q because we don't know what they are. But we do know one thing, right? That if we want H plus Q, We just need to go ahead and move this to the other side. Remember the old rule which said change sides? You remember this?
Yes, I
Or
remember that.
change sides what? Change sides, change signs,
Signs,
right?
yes, yes, yes.
So we're gonna go ahead and move these two to the other side, but we're gonna change the sign. Why? Because we're adding the opposite to both sides. You see what I mean? So we get 1 minus 1/3 minus 1/5, okay? So now, let me go ahead and throw 1 under there so you can see that's a fraction too. What's the LCD?
15?
Nice. So what is the first denominator going to need? What do you need to multiply the first denominator by to make it 15? 1 times what gives you 15?
15.
Nice. So make sure you do the same on the top. 3 times what gives you 15?
5.
Right. Don't forget to do the same on the top. And 5 times what?
3.
Right. So notice all 3 denominators are now what? The first denominator is now 15. What's the second denominator? Well, that's 15 too, right? And so is what? The third one. So now these are like fractions, right? So now we can just combine the numerators. All right, so help me out here. The first one is just going to be what? 15, right? Minus what?
5.
Good.
Minus
And then minus?
3.
Very nice. So that's 15 minus 5, which is 10, minus 3, which is?
7.
You see where that comes from now? All right. Very nice, guys. Very nice. Nice participation, by the way. All right. If you don't have any more questions on this, I'm going to go ahead and erase it, right? All right. So use the list of equivalent units in the table to the right to answer the following questions. If a person buys 28 gallons of gasoline, how many liters of gasoline is that, right? So here what we're using is what's called a unit factor, okay? They're extremely useful. So here's what you do. You write down what you're starting with. What are we starting with? We're starting with 28 gallons, right? Now, we're going to multiply this by, I'm trying to get from gallons to what? Here's the game plan.
Gallons to liters.
Right. So here's our game plan. All right. Now, do I have a conversion directly from gallons to liters?
No.
No.
Okay, so what do you think we're going to do? Well,
Okay.
here's the game plan. We're going to go from gallons to what first?
Quarts.
Exactly. And then we're going to go from quarts to what? See?
Liters.
Exactly. And the way we're going to do it is using really nice concept called unit factors. I'm going to want a fraction here where the numerator and denominator represent the same quantity, right? But in different units. So because I have gallons here, I want gallons down here so they cancel out. You see what I mean? So since I'm going from gallons to quarts, I'm going to want quarts up here. Okay. So what's the relationship? What numbers should I put next to these guys? Remember, 1 gallon is the same as what?
4 quarts.
4 quarts.
You see this guy right here? that's what we call a unit factor. Let's see why we call it a unit factor. Unit, because what's the value of this? Remember, the top and the bottom, they're the exact same quantity, right? So that means you can cancel them completely and get what? Get 1. That's where the unit comes from, right? Unit means what? Means 1. And why is it a factor? Because what are we doing? We're what? What's the operation?
Multiply.
Multiplication.
Right. What's each? So when you have like 3 times 4, each of these is called a what? Is called a factor. And this guy here is called a what? Product, right? So because we're multiplying it, it's a factor. Why? Because that's what a factor is, okay? Something that's being multiplied. All right. So now we'll go ahead and bring in one more unit factor to wrap this up for us. Because this is just gonna, look, here the gallons are gonna cancel, and if we just stopped right here, we'd have an answer in quarts, right? But we don't want the answer in quarts. We want it in what?
Liters.
Right, so we're gonna go ahead and multiply by, what do you think? What do you think this unit factor is gonna be? What should I have down here? Let me start with that. What unit should I have down here? Don't forget, I have quarts up here, so what do I want down here? The same, so that they what? They cancel out, you see? So what unit do we want up here?
Liters?
Liters, yeah.
Exactly. So what are the numbers that are gonna go next to them? That's where this information is gonna come from their relationship. You see what I mean? 1 quart is what? 0.946 liters. What does that mean? That means this quantity and this quantity are exactly the same. So you can cancel them out and get what? Get 1. Therefore, this is also a what? A unit factor. You see what I mean? The nice thing is you can have as many unit factors as you want, because what are you doing? You're taking 28 gallons, you're multiplying it by 1, you're multiplying it by 1 again, right? But the 1 is in a very useful form, right? So it helps us get to a different unit. All right, so now watch what's left. So let me go ahead and get rid of this. Okay, so now let's see what's left. So first of all, we notice that gallon cancels gallon, right? Quart cancels quart, right? And what's left? Well, this is what's left. Okay, number-wise, what's left? 28, right? Oops, let me go ahead and go back to the color. All right, so what's left? 28, right? Times what?
4.
Yeah, remember all of those are on the top, right?
Yes.
Times what? Times 0.946, right? And what about the denominator? What's the denominator?
Is it 1?
Right, so do I need to write it?
No.
No, so, and what's the unit that's left? What's the only unit that's left?
Liter.
Remember, gallons canceled gallons, quarts canceled quarts. The only unit that's left is what? Liters.
Liters. Mhm.
Nice. So now we're going to go ahead and multiply that out, all right? So I had a calculator here somewhere. Let's see here. By the way, make sure you get comfortable with using this class calc on your mobile phone, because you're going to be using it on the test, right? So you're basically, I'm going to run you through that today before we leave, okay? So don't let me forget. One of you remind me, okay?
Okay, yeah, because I don't know how to use that.
Yeah, I'll show you. It's not a big deal. All right, it's very easy. And we'll make sure that it gets installed properly on your phone, and also it'll be nice because it'll be on the video, so everybody will have a chance to learn it. All right, so let's go ahead and type in. So we have 28, right? Times what? Times 4 times 0.946. And that's where the 105.95 comes from. You see that? The only thing is it says round to 2 decimal places as needed. So that's why the 2 was dropped, right? So when you have, let me make this larger. Actually, there it is, okay? So when you have 105.952, right, and you're rounding to 2 decimal places, that means you have to look at the third one. Now, if the third one is 5 or more, you would have rounded up, right? The 5 would have become 6, and you would have dropped the 2. But since it's 2, you just what? You just drop it and you keep the 5, right? So some people incorrectly say round down or round up. No, you're never rounding up or down. You're just what? You're just rounding. It's just that based on the rules, sometimes you end up rounding up. Sometimes you end up rounding what? Down. But we're going to have some situations that we'll see in statistics that you'll always, for example, want to round up. You see what I mean? That's a different scenario. That's when we specifically tell you always round up, just to be safe, right? So, but that's a different scenario. In general, rounding isn't always up or what? Or down. Sometimes it's up, sometimes it's what? Down, right? All right, guys. So that's that. Any questions on that? Any questions?
No,
No questions.
thank you.
Okay. So a student tries to find this product, 2 times 3/5, and what they do is they say 6/10. And so what do you think they did wrong? What did the student did incorrectly here? They basically multiplied the 2 both on the top as well as the what? The denominator, right? And that of course is wrong, because when you see 2 times 3/5, right? Really, that's the same as what? 2/1 times 3/5. That's why you should always put those invisible ones in, so you don't make the same mistake. Then you multiply what? Across, and you get 6/what? 5. All right. Any other questions on 1.3? Anything on 1.3? Should we take a look at 1.4? All right, 1.4. Let's just do that. Okay. Here we're dealing with opposite numbers, right? That's easy enough. Let's see. What's the opposite of -10? When you read this, right? If you want to read this in just plain English, right? With no, as little mathematics in it as possible, you would just read this as what? The opposite of this number, which is what? -10. So what's the opposite of -10? That's 10, right? Here, how do you read that? Do you know? Read that for me.
Absolute value,
Right. You say the absolute
7.
value of 7.
7.
Okay. Good. And of course, remember, the absolute value of any number is the distance between that number and what? Distance is always between two things, right? So what is the absolute value of x? The distance between x and what? It's always the same thing. Anybody?
0.
That's it. Okay? So when you think absolute value, think distance from what? From 0. So here is 0. Here's 7, right? What is distance? Distance is the number of units between two numbers, right? So let's say these are the units 1, 2, 3, 4, 5, 6, 7, right? How many units between 0 and 7? 7. So that's why the absolute value of 7, which is the distance between 7 and 0, is just going to be what? 7, right? What if I wanted the absolute value of -7? See, that would be over here, right? But notice 1, 2, 3, 4, 5, 6, 7. The same number of units, right? Between -7 and 0. This is why the absolute value of -7, which is also the distance between -7 and 0, is also what? How many units between -7 and 0?
7.
7.
Right. So that's why. So this is why absolute value never gives you a negative answer, right? Because absolute value is distance. And remember, distance can never be what? Distance can never be, finish the sentence, can never be. The distance between two objects can never be negative, right? Distance just means how many units are between two things, right? What's the worst case scenario for distance? What is the smallest possible distance in existence? What do you think? It's the distance between a number and what? Itself. What's the distance? What's the distance between some number and itself?
0.
Exactly. So that's the worst case scenario for distance, right? Distance cannot be smaller than what? Smaller than 0, right? Because if two numbers are not the same, there's going to be some distance between them, right? Some number of units between them. So if they're not the same, the distance is definitely going to be positive, right? And if the numbers happen to be the same, so the distance between them is going to be 0. So distance is always greater than or equal to 0. Now, we have a mathematical term for that, right? Because remember, if it's just greater than, you can just say what? You can say positive, right? If some quantity is greater than 0, you can say that quantity is what? Positive. But if some quantity is either greater than 0 or positive, or 0, I'm sorry, either greater than 0 or 0, then you can't say positive anymore, because 0 is not a what? 0 is not a positive number, right? So the name that we have to include all of those, we say distance is always. Does anybody know how to finish this sentence? What's the magic word here? It's not positive. So what can it be? I'll give you a hint. Well, I gave you more than a hint. I told you. All right. It's non-negative. That's how you say it, okay? So we came up with this whole word. Notice no space, no dash, nothing. One word, non-negative. That just means what? That means either positive or what? or 0?
Or 0.
Exactly. So out of respect for one number, namely what? Namely 0.
0.
We had, exactly. So out of respect for this one number, we had to come up with this whole new what? Whole new word. Okay, that's how important 0 is. Don't ever underestimate the power of 0. Okay, so remember, absolute value. When you think absolute value, I want you to think what? What do I want to come to your mind when you think absolute value? Distance. Okay? And when you think distance, I want you to think what?
Non-negative.
Exactly. Since absolute value is distance and distance is always non-negative, that tells you what? Absolute value is always what?
0?
No,
Non-negative.
non-negative, right? That's why. Okay? So there we go. Okay, so here with something like this, make sure you take care of the absolute value part first, right? So what is the absolute value of -5? Just this part. Focus on that. What is that?
5.
That's 5, right? So this negative is going to carry. So the answer is actually what? Right. So a lot of people, they make a mistake. They go, oh, this problem has an absolute value in it. The answer is going to be what? Positive. No, not if there's an absolute, then a negative sign outside the absolute value. That's going to carry and stay. So the answer is actually what? -5. With these, let me give you my little general lesson on these, okay? Because I have an easy way you can always get these right. So I want you to learn 2 sets of rules, okay? One is I want you to learn the rule for what is that close? Here we go. I want you to learn the rule for let me actually use Microsoft's own pen. All right. So these are the multiplication and division rules, right? So do you know the rules? Let's see. What is positive times positive? What if you multiply 2 positive numbers? What kind of outcome do you get?
Positive.
Good. And what if you multiply 2 negative numbers?
Negative.
Right. Think of it this way. The opposite of a negative number is a what? Right? Think of the first negative as the opposite. And the other one is a negative number. So what's the opposite of a negative number? A positive number. Make sense?
Yes.
All right. So what is positive times negative?
Negative.
Good. And what is negative times positive?
Positive.
No, that's also negative.
Oh, okay.
Yeah. Anytime you multiply 2 numbers with different signs, you get negative. Whenever they have the same sign, you get what? Positive. So let me give you those rules in a really nice table. So remember, this works with multiplication or, oh, that didn't work out too well. Let me try this again. It works with both multiplication or division, okay? So let me put it like this. You can make a nice table here, times table. So you have positive like this, okay? So positive times positive is what? Positive. Positive times negative, negative. Negative times positive, negative. And negative times negative, positive. Got it? So those are the rules for multiplication and division, okay? Now, the rule for addition and subtraction, I'm going to use an example to get these across, okay? So what if we have like, what if we combine two numbers and they have the same sign? For example, 2 plus 5 or -2 minus 5. See here, both of those are positive. Here, both of those are what? Negative. Now, in both of these situations, the operation involved is going to be what? What's the operation going to be?
Addition.
Exactly. And in both cases, you just keep the common sign, right? Of course, if it's +7, you just put in what? Into my like math Excel. You're just going to type in 7, right? That's the simplest version of +7. Now here, you're going to go ahead and combine the numbers, ignoring the signs. In other words, combine the absolute values of the numbers, right? So you get what? You get 7. You're going to keep the sign that's common. What's the common sign here?
Negative.
Negative. So, right. The best way of thinking about this is think of money and your bank account. Let's say you have $2 in your bank account. That's positive $2. You deposit $5, so you're obviously going to have what? $7 now. What if your bank account was $2 overdrawn and then you wrote a check for $5 too? Obviously, it's going to become even more negative, right? So that's why you get -7. So to combine two numbers that have the same sign, you're basically going to do what? You're going to add and keep the common sign. Now, to be really theoretically sound, you're just going to say add the absolute values, right? Like that. So what if you have opposite signs? What if you combine two numbers that have opposite signs? Such as 2 minus 5 or -2 plus 5. Think of it this way. When the signs are opposite, you're going to get less of either, right? So that means the operation involved is going to be subtraction. Subtract the smaller number from the larger number. Of course, we're talking about absolute values, right? So subtract 2 from 5, you get what? 3. But since 5 is the larger number, you're going to take that sign. So the overall result is going to be -3. In other words, you had $2 in your bank account, but you wrote a check for $5. The bank knows you, so they went ahead and paid it. What's your balance going to be now? It's going to be -$3, right? All right. How about here? You have you're overdrawn at -$2. You go ahead and deposit a $5 bill right into your account. What's your account balance going to be now? +3. Notice once again, what was the operation? Subtraction, the absolute value of the smaller number taken away from the absolute value of the larger number, and then what? Take the sign of the larger one. So when the signs are opposite, we're always going to subtract, and we're going to take the sign of the what? The number with the larger absolute value. Make sense? Like that. Okay, so let me go ahead and bring a new. All right, so now let's say I give you a problem like this. Well, the positive cases are real easy, right? We're not going to waste time on that. We'll just do a couple. Like if you have 3 plus 7, what is that? That's just 10, right? Now, the more interesting ones are when the signs are different, right? So what if you had -3 plus 7. Tell me what the operation is going to be first of all. Addition or subtraction?
Subtraction.
Right. When they have, remember, it's very easy. Same sign, add. Different signs, always subtract. Subtract what? Subtract the smaller number, the number with the smaller absolute value from the number with the larger absolute value, right? So 3 from 7 is what? Subtract 3 from 7, what do you get?
4.
Right. Now, what sign are you going to take? The sign on the left side of the larger number, right? So here, you're going to take what? Positive. So it's going to be what? 4. Make sense? Now, let's say we have -2 minus -11. In situations like this, where you have parentheses involved, I want you to, this is the reason I gave you the multiplication division rules first. I want you to get rid of the parentheses in this way. Go ahead and write the -2. Now here you have negative times negative. What's that going to be?
Positive.
Exactly. Now apply the addition subtraction rules. These are opposite signs, so what's the operation going to be?
Subtraction.
Good. 2 from 11 is what?
9.
And the sign is going to be, which one has the larger number? 11. What's the sign? Positive. So we're going to write what? 9. Try this one. Try that one on your own for a minute. By the way, I want to remind all of you that I am available during office hours every week, as you know. Mondays, Tuesdays, Wednesdays from 12 to 1. It's the same Zoom address that you came to get here. So keep that handy. And it's also in the top module of your Canvas, the link. So make sure you come in and see me there too if things start to bother you. Don't let things pile up, okay? All right, so since there are parentheses here, we'll take care of that first. So you get what? You get -7 and then what?
+2.
Exactly. Now apply the positive addition subtraction rule. Because they're different signs, what's the operation?
Negative.
Subtraction, right? 2 from 7. What's 2 from 7? What do you get when you do 7 take away 2? What do you get?
-5.
But you get 5, right? But then you take the sign that's on the left of the bigger number, right? The number with the larger absolute value. So what do you get? -5, like that. All right, let's try this one. Okay, go ahead and try that. Remember, I threw in a little bit of order of operations in there too, because you know how that works. PEMDAS, right? Or please excuse my dear Aunt Sally, right? You're going to do grouping symbols first, right? From the inside out. Then you're going to do any exponents, then multiplication and division. And remember, for those, you just go from left to right. They have the same strength. So these ones, you just go left to right. And then addition, subtraction, also from left to right. These two are also what we call equipotent, right? All right, so take care of this first, right? Okay, so 1 plus negative 8 minus what? We're not getting rid of parentheses yet. Minus what? What do you do here? They're both negative, same sign. What do you do when they have the same sign? What's the operation?
You addition,
You
add.
add. So you get 14 and you take the common sign, which is what? Negative, okay? So negative 14. Now let's get rid of the parentheses. So we get 1. What's positive times negative?
Negative.
So minus 8. And what's negative times negative?
Positive.
So plus 14, right? So now 1 minus 8, take care of that. They're different signs. What's the operation? Positive 1 minus 8. You're combining two numbers with different signs. What's the operation?
Subtraction.
Right. 1 from 8 is what? 7. Take the sign to the left of the larger number. So negative 7. And then plus what? Plus 14. So now what's the operation?
Subtraction.
Good. What's 7 from 14? 7. And take the sign up to the left of the larger number, so positive. And of course, you're just going to type in 7 as the final answer. You see how that works? Nice and simple, right? When you do it like this. All right. Any questions on this business before we move on? All right, let's go back to here. Now it should look real easy to you, does it? What do? Let's get rid of the parentheses. We have negative 2 minus negative plus negative 8. All right, so to get rid of the parentheses, we're going to multiply those, right? So because remember, always remember, there's an invisible what? 1. And this is a multiplication. And remember, you just saw PEMDAS, right? And when you deal with PEMDAS, right, the order of operations, multiplication comes before what? Before addition or subtraction. You see that? Multiplication and division come first. So that's why you have to take care of this first, right? So what's positive 1 times negative 8?
Negative.
Right. So we get negative 2 minus 8. And what is this now? Well, they're the same sign. So the operation is addition. What do we get? 10, and we keep the common sign. So negative 10. Is that easy or what?
Yes.
Good. All right, let's go then. Same here, right? We get rid of the parentheses. So that becomes 8. Positive times negative is what? Negative. Different signs. So the operation is subtraction. 3 from 8 is 5. And the sign of the larger number 8 is positive. So it's going to be positive 5. Of course, what do we type in here? Just 5. Never type in the positive to the left of a positive number, because that's not the simplest form. The simplest form is that. Okay? Here we get what? We have negative 12, right? Positive times negative is what? Negative, right? So that's negative 12 minus 3. Now, We're combining two numbers with the same sign. Operation. What's the operation when they have the same sign?
Addition.
Right. And which sign do we keep? Well, there's only one sign, right? The way we say it, we say add, keep the common sign, right? Like that. So that's going to be negative 15. Now that's easy. What's negative 11 plus 11? That's just that's always true, right? The opposite of a number. The opposite of any number added to the number itself will give you what?
0.
0, always, okay? And it doesn't matter if it's like that or if the x comes first, the positive one, then the negative one. Same business here, right? That's also 0.
So x can be a fraction and it's always
Absolutely, absolutely. So you can have negative 2/3 plus 2/3. That's also 0, right? Or you can have 2/3 minus 2/3. That's also 0. Of course, because the rule is this. When you have a over c plus b over c, right? You keep the c and you combine the a and b. And if it works with addition, it also works with subtraction, right? So that's why when you have negative 2/3 plus 2/3, basically you keep the 3 and you combine the numerators, which are negative 2 plus 2, right? Now what's negative 2 plus 2? That's 0, right? And what is 0 over 3? That's 0. See? Sometimes people incorrectly say that's undefined. No. Undefined when the 0 is where? On the bottom. That's undefined. In fact, you can't even divide 0 itself by 0. That's also what? Undefined. In other words, never divide by what?
0.
By 0, okay? If you do, you're going to get an undefined answer. Now, later when you go into more advanced classes, you'll realize it's a form of infinity, okay? But as far as pre-advanced math is concerned, it's not going to be a real number, so we call it what? We call it undefined, okay? All right. Easy, right? What's the operation? They're different signs, right? What's the operation?
Subtraction.
Subtraction. When you subtract, you get 54. Why you keep the negative? Because that's the sign on the left of the larger number. You see how it goes? Very easy. Same business here. Just get rid of the parentheses first. Positive times negative is negative. And then you're going to have negative 247 minus 887. They're both negative. Now you do the addition subtraction rules. You're going to add because they have the same sign. And you're going to keep the common sign, right? Same business with decimals, right? Here's a fractional one. Let's do this one. All right, we have negative 7/15, right? What's positive times negative? Positive times negative?
Negative.
So minus 4/5. Remember, when you get all these parentheses, it gets a little bit confusing looking, right? Best thing, just get rid of the parentheses first. All right, this is different, by the way, from the way the PowerPoint shows you, right? So it's an alternative way. Some people are more comfortable with the way the PowerPoint shows you, the Pearson PowerPoint. Some people are more comfortable the way I'm showing you. So take your pick, makes no difference. I'll accept both as valid methods, okay? So here, we're gonna need an LCD, which is what? What's the least common multiple of 5 and 15?
15.
Exactly. So now the first denominator is already 15. We don't have to do anything here, right? But this one, we have to multiply it by what?
3/3.
Yeah, well, by 3 here, so make sure you multiply the top by 3 as well, right? Or you can think of it as multiplying negative 4/5 by 3/3. Same thing, okay? That didn't go very well, did it? Let's try it again. So negative 4/5 times 3/3. Or you can just think of it as multiplying the denominator and the numerator each by what? By 3. Same thing. All right. So we end up with what? What's the first numerator?
7,
Try again.
negative,
There you
negative
go.
7
And then minus
minus
what?
12.
12. That's it. Now just combine negative 7 and negative 12. Remember, they're the same sign. So what are you going to do? Since they're the same sign, what are you going to do?
Add.
Right. So you're going to get 19 and you keep the common sign, right? So negative 19 over 15. Now, the best way to answer that is to actually put the negative on the side, right? Then draw a fraction line right in line with the negative and then put the 19 over what? 15, like that. Is that clear then?
Yes.
All right, good. Person bounces several checks and is charged a service fee such that the balance of the checking account is negative $75, okay? So in other words, the current standing of the account is at negative 75. That's the current what? Balance, right? Then the person deposits 300. What's the new balance? So tell me what operation should I write down in order to figure this out? What should I write down? In other words, you know how when you take a test, for example, I want you to show me the work and then take pictures of it and send it to me after the test. So what do I expect to see on your answer sheet, on your worksheet for this problem? It's going to be an operation. What should I write? Well, what's your starting balance?
Negative 75 is
So
the
you
starting
start
balance.
with that, right? And what do you do then with the 300? Are you adding it, or are you? Is it a withdrawal or is it a deposit?
Deposit.
So it's going to have what kind of sign?
Plus.
So plus 300. That's exactly what I expect to see on your worksheet, right? On a problem like this. Very simple, but this tells me you know what you're doing, right? All right, so then here, what's the operation going to be? They're different signs, right? When two numbers have different signs, what's the operation?
Negative.
Subtraction, right?
Mhm.
And what's the overall sign going to be of the result?
Positive.
Right, because the larger number is what? Positive. So 75 from 300 gives us what? 225. So the final balance on the account is what? That's the current
225.
balance. That's it. All right, so look at this. So a check register is shown. Find the final balance of the checking account. Do me a favor and go and see if you can get this number. Go give it a try. You can use a calculator, by the way. In fact, I'm pretty much gonna end it soon. This session, I don't want you to get too. The human brain can only handle so much math, right? So So we're gonna end this pretty soon. So go ahead and do me a favor. If you don't have Class Calc on your mobile phone yet, go ahead and download and install it, and then handle this problem and make sure you get that. And then I'm going to tell you something about Class Calc. Okay, so do that for now. Let me get my own phone to show you what it looks like. So what kind of phones are we dealing with here today? Android or iPhone or both?
I have an Android and I already downloaded it on my phone.
Okay, good. And Casey, what do you have?
I have an iPhone.
Okay, so good. So we have both. Perfect. Because they're different. The way the self-lock applies are different. And my shy friend here, F. Alvarez.
Yes. I have Android and I've downloaded it.
Are you Fabiola?
Yes.
Fabiola, you got to participate. Nobody can see you. All right. No, I'm just kidding. Be comfortable. I don't honestly.
Alrighty.
No, just do what you want. If you want to participate sometimes, we won't judge you, I promise. All right.
Actually, I was answering a few questions, so yeah.
Okay, good. I just didn't notice it. I'm sorry. Thank you.
No worries.
That's great. Okay, so guys, what do you have, Fabiola, by the way?
I have an Android and I have it downloaded already.
Okay, so everybody has it downloaded?
Yes.
Yeah.
All right, so
Yes.
now here's what, let me go ahead and launch mine. I want to show you. Okay, so on both our phones, whether it's an iPhone or I need to get rid of the virtual background real quickly. Okay, so they all look like this basically, right? Whether it's iPhone or Android makes no difference. So by the way, you don't have to necessarily log in. If you want to, the easiest way is to log in using your Gmail, okay? But you don't need to. Just click on this top left, right? And you see down there, it says self-lock. Do you see it? Go ahead and choose the self-lock option. Then you get this, right? Go ahead and push continue. Now, so what are you seeing on your phones right now? Talk to me. It's asking you to go to settings, right?
Mine says pin mode. Click here to activate pin mode.
Okay, so go ahead and click here to activate PIN mode.
Okay.
Yeah, the ones on Android should be getting these settings notices. Are you getting it?
No, mine says self-lock begin. You began self-lock at, and it says start the date and
You
time.
must have done this before. Did you try it before?
Yes.
Okay, so that's why. How about was it Katie? Was it you with the iPhone?
No.
Who was it with the iPhone?
It's me, Casey. I tried it on your first Zoom meeting.
Okay.
So
And-
yeah, it's working for me.
Okay, perfectly. All right, great. And then when you're finished, you know what to do, right? Go ahead and hit exit self-lock, exit lock on the top left. And it's going to tell you, okay, go ahead and exit self-lock again. Now, once you get this green text on the bottom, right? Don't quit, please. Because on test day, I want you to go ahead and just learn how to do screenshots on your phone, right? On mine, it's easy. It's power and volume down, right? I think on the iPhone, it's power and home button, okay? Take this screenshot. When you're finished with that screenshot, lay down the pieces of paper on which you've done your work to take the test, right? And go ahead and open the camera on your phone, snap, 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 right? Then you're gonna just do an attachment, right? You're gonna share, right? Just choose share through email. You're gonna send me an email. So just, it's on your syllabus, farzinr@laccd.edu. Just make sure to include this, right? This screenshot that you took and the pictures of the test worksheets that you took, and then email them all to what? Just make sure that you put Math 137 in the subject of your email. That's all, okay? Math 137. Then go ahead and just send me one email, please. Don't do each as a separate email. Just one email, attach all of those pages to it. It's a piece of cake. Once you do it once, it's completely easy, okay? So then you'll be good to go. So all right, so now that you all have this class calc, go ahead and see if you can get to this answer. So I'll replicate it here on my class calc on the desktop. So what do we start with? Oh wait, you can't see the screen, can you? All right, so what should we start with?
Negative 50.
Right, so we start our computation with negative 250. Oh wait. So negative 250, and then what?
Add 476.
Right, because these are deposits, right?
Mm-hmm.
And then?
Subtract 8365. And
Okay,
subtract 4116. And
okay,
add 771.
exactly what you do, okay? Here, these are gonna be adds, right? Because they're deposits. These are gonna be what? Subtractions, okay? They're payments. So in other words, you're writing a check to what? To your insurance company. You're writing a check to your what? Phone company, right? So those are gonna be subtractions from your account. These are gonna be additions, and that's the original balance. All right, I think we're good for now. How was that? Did that help you out?
Yes, it did.
Yes.
Good. So yeah, just keep coming to these things, and don't forget. I'm also available on. It's on your syllabus. Just quickly show you real fast.
So I have a question regarding the homework. I know that I read your email that for us that work full time, that
Right.
you're allowing us to submit it by Sunday. So I actually did mine like the day after. So when we go in there, when I went past the due date, it didn't give me the option where it says improve my score. But I did see it today. I had already submitted the
Okay,
homework.
if you didn't see it, you probably weren't past due yet.
Oh, really? Okay, I thought I was.
No, only
Because-
when you'll only see that if you're actually past due. So let me go into your
Okay,
student
because I
mode.
know I did it like the next day.
Okay,
I think one, yeah.
let me show you something. You see, these are all past due, right? These three, right? As a student, I'm not very good, right? I haven't done much. So you see, because I get a student account too. if I, oh, I see what you're saying. So here it's not showing me. Oh, okay, okay. You know why you're not seeing it? I think I'm realizing when that happens.
Okay.
You're not seeing it because you haven't done anything, okay? But because I've allowed you to work past due, so you just go ahead and start. Now let me go back. I believe if my theory is right, you should see it now on something like this, which I have done something with. See, if you've already done something and you've got a score, right, but you haven't completed it, that's when you get the improved score option, right?
Mm-hmm.
But if you haven't done anything, you won't see anything. Just start doing them.
Okay, but I did do mine.
Yeah, that's
And- yeah.
but
Okay, and so that's why it shows improved score.
right. That's
Okay,
when
gotcha.
improve score. If there is a score to improve, right? When you haven't
Right,
done
okay.
anything, there's no score to improve, so you don't get that. But you can still do it. All right?
Okay.
Any other
Thank
questions?
you.
You got it. Okay, guys, so I will see you next week. I won't, there's nothing going on Monday, no class, no homework assigned, no nothing. So enjoy your Labor Day. But starting on Tuesday, I'll have office hours again. So by all means, contact me then. Or even if you can't make it to those times, if you let me know, I'll try to set something else up for you guys. Okay. So, I'm here. So don't think you're up in the air. Don't worry. You are in cyberspace, but there's support in cyberspace. So don't worry about it. Okay. All right. So I'll see you guys next time. Take care and be good. Bye. Stay
Thank
safe.
you.
Okay. Bye bye.